Sorry, I'm going to put back my face. Whoops. No, not that. So it's a pleasure to welcome Penny PEXMAN from Calgary and in Calgary as she's here. I'm going to, je vais présenter ça d'abord en français, ensuite je passe le volant à Penny. Penny est professeure de psychologie à l'Université de Calgary. Elle travaille sur la dénomination des choses, ce qui est très important pour tout ce qu'on veut faire avec le langage et la computation. Elle va nous parler, un instant, je cherche l'exposé. Voilà. Elle va nous parler de l'ancrage, vous savez déjà ce que c'est, les concepts abstraits. Je vais poser une question à Penny tout de suite. What is the difference between a concept and a category?
Well, I think that's I'm not sure there always is one. I tend to focus on the things that we have labels for. And so I think concept tends to work better, but many of the things that we are talking about as concepts obviously refer to categories. So I'm not sure it's a critical distinction, but you probably could drill down and make one.
My guess is that concept is a term of art. And if you make it into something concrete, it always ends up being a category. But anyway, I'll continue in French. Elle va nous parler des concepts, ce qui veut dire à peu près la même chose que les catégories abstraites, les catégories abstraites. Et elle va nous expliquer le rôle de l'information sensorimotrice ainsi que d'autres sources d'information. Et avec ça, elle est directrice du laboratoire Language Processing Lab à l'Université de Calgary. Et avec ça, je passe ça à Penny. Penny, it's yours.
Thank you. Well, it's a pleasure to get to chat with you this morning. I want to tell you about the work we've been doing, trying to understand how it is that we learn and represent, retrieve, remember abstract concepts. But to get there, I need to first talk about concrete concepts. So let me begin with something that I think is widely assumed and non-controversial. And that's the idea that, at least in childhood, particularly in infancy, many of our early concepts, categories, words are acquired through sensorimotor experience. So these are pictures of my own kids. My son, as an infant, as many infants do, keeping objects in both hands. So this is something you see if you walked into a daycare, you would see every child holding at least two objects and holding them, putting them in their mouths and fighting over them. And this is my daughter experiencing sand for the first time, which of course involves putting your feet in it, putting it in your hands, and ultimately ingesting a considerable amount of sand. So early on, this is how children learn about the world. We've known this for a long time. The question that I've become interested in is what happens after that. And there are surprisingly sparse data points once you get beyond infancy. So we know, as I said, from work by people like Piaget and the writing of Maria Montessori, that children's early concepts emerge out of sensorimotor interactions. And there are data from more recent decades showing some very interesting relationships. So, for instance, when a child becomes capable of sitting on their own, there are changes in their perception of objects, largely including perception of a third dimension of depth. And that's been shown in some really interesting perceptual experiments. The transition that children make from crawling to walking, we know leads to more instrumental actions with objects. They can share things with more people and engage in joint attention. There is this kind of burst in learning that happens as soon as their hands are free, and they expand the reach of what they can interact with. And then there's some very nice data from studies by Linda Smith's group, where babies wear tiny GoPros and engage in free play, and then they track language acquisition afterwards. And what they find is this direct relationship. This is the closest to causal data that I know of. They find this relationship between what the child sees in their field of view, because their field of view has been tracked with these GoPro cameras, what they hold, and what they subsequently learn labels for, suggesting there is this direct relationship between sensory experience and subsequent language learning. So this has all been well established, but as I said, my question has been, what happens next? So became interested, as many people did, in this notion of embodied cognition. So a sense that we need to consider the input and output systems that that humans have as they acquire information about the world, as they retrieve information about the world. And so the gist of this, which I'm guessing you are quite familiar with, this is from this is a figure that we generated for a review paper that's currently in press at Nature Review Psychology, where we just demonstrated, if you take a concept like football, what are we talking about when we talk about embodied cognition? Well, it's this notion that when you think about football and remember football, you are simulating some of the same sensory motor states that were involved when you learned about it in the past, when you engaged with football in the past. The alternative is something more classical and typically called amodal. And two examples of those kinds of accounts are feature lists and semantic networks. And in fact, you could talk about a continuum of embodiment to frame this work. So although I've been talking about, so I've mentioned embodied cognition, and there is certainly a strong version of embodied cognition, which is represented on the right side of this slide. But there also are many points in between. And as with many debates, most people working in this space land somewhere in the middle in terms of their theoretical position. So the continuum ranges all the way from symbolic or amodal to strong embodiment. But these midpoints are the part of this continuum that have been developing quite rapidly in recent years, as people consider how meaning information might be best represented, best accounted for in terms of models. So something like multiple representations or hybrid accounts are becoming very popular, where you talk about, yes, sensory motor information is important, but so are other kinds of information. And those other kinds of information are important in order to be able to account for things like abstract concepts, which we're going to dig into, but also other aspects of semantic processing and semantic memory. So when I first got into thinking about sensory motor information and how it might be important to concepts, and thinking about the embodied position, the strong embodied position, I came at this as someone who'd studied language processing and lexical processing, and thought about, okay, well, what does embodied cognition predict for someone who is, as I like to call myself, a word nerd, right? So I study tasks that involve words and sentence stimuli, and look at how people process those. So what does embodied cognition say for lexical semantic processing? Well, one of the things it says is that even if you're not interacting with the concept itself, even if you're just looking at a word on a screen or reading a word in a sentence, you should still, in order to process the meaning, generate the meaning, retrieve the meaning of that word, you should still be evoking aspects of your previous sensory motor experiences with the referent in order to generate the meaning. And so you are simulating aspects of sensory motor experience in order to retrieve meaning. So if you couple that assumption with another assumption, which we call semantic richness, this is the kind of general phenomenon that when it comes to lexical semantic processing, more is better. And what I mean by that is words that are associated with more meanings, more associates, more features, more previous encounters, all of those things tend to facilitate processing. So a richer word, because by virtue of having more of these things associated with it, tends to be processed more quickly, more accurately, remembered better in lexical semantic tasks. So if you put these two
Can I
things
ask you a
together,
question?
sure.
What is the difference? What do you mean by meaning? What's the difference between meaning and referent?
Well, I think referent is the thing that we're talking about the meaning of. Meaning is something that is that captures what you know about the referent. Is
referent the thing that we're asking the meaning of, or the word that we're asking the meaning of?
I would say it's the word, by virtue of the way we've approached this. I think there are other tasks and paradigms where you could be talking about something different, but I'm talking about things that can be labeled, and I'm talking about retrieval through the label.
And I'm a little mixed up. I asked you the difference between meaning and referent, and you said the referent is the thing that you're talking about, and the meaning is the meaning of the referent. But now you said it's the meaning of the word that refers to the referent.
Well, I would say the word is the pointer to the concept. And when we say referent, it's linked to the word. So the referent is the thing to which the word refers. I don't think referent by itself is something that is necessarily meaningful. And so when I talk about meaning, I'm focused more on the thing to which the referent points.
Word points. Oh. The thing to which the word points.
To the thing to which the word points.
Okay.
Yeah.
Go ahead, please.
Okay. So if you couple these two things, you land with this prediction that words that are associated with more sensorimotor experience should be processed faster, more accurately, remembered better in lexical semantic tasks. And so that was a prediction we set out to test. In order to do that, we had to come up with some way of quantifying relative sensorimotor experience for words. And so characterized this dimension that we called body-object interaction, and asked people to make ratings of individual words. And the rating scale was described as the ease with which the human body can physically interact with the words referent. We did use the word referent when we asked participants about this. We didn't define it. And so we gave them a 7-point scale, and thousands of words have now been rated over a number of different studies, and they're all available publicly for use in research. And what we found was people were pretty reliable. So they had consistent ideas about the ease of physical interaction. So things like lightning got low ratings because obviously it's very dangerous for the human body to physically interact with lightning. Things like wreath were moderate on the scale, and then a word like ball is one of the highest rated words for body object interaction. There are lots of ways that the human body can easily interact with a ball. And so that was interesting, but more important was the question of whether this dimension matters for behavior. So remember, the prediction is words that have high amounts of sensorimotor experience should enjoy a processing benefit. And that would indicate that sensorimotor experience is a dimension of meaning that people are retrieving when they think about these concepts and make ratings of them. So we have done a number of studies looking at behavioral effects of body-object interaction. So have many other people. I wanted to show you one example of one of those experiments. So this is a sentence reading task. So participants were reading sentences on a screen. Their eye gaze was being tracked with an eye tracker. They periodically answered comprehension questions to ensure that they were attending and understanding the material. And we constructed the sentences with a lot of care so that each sentence frame was an equally good home for either a low BOI word or a high BOI word. So in that first example, Judith saw the reflection of the sun or cat in the oval mirror. Sun is low BOI and cat is high. And in the second example, frost is low and purse is high. And the words across sentences were matched in every other way. So we've got a set of low BOI targets, a set of high BOI targets. They are equally frequent their length is equivalent, and all the other things that matter, things like imageability, concreteness, that also matter for sentence reading, were matched across the sentences. So as far as we know, the only difference between these two sets of words is their BOI rating. And what we found was that there was a BOI effect in the context of sentence reading. There are a lot of different things you can look at in eye tracking data, but what we looked at here, what I'm showing you here, are two of the aspects of the data. One is the total fixation duration, so how long people landed as they were reading, how long they landed on the target. And what we found was that they landed for less time on those high BOI targets, suggesting they were able to retrieve and integrate the meanings more rapidly than for low BOI targets. They also looked back less frequently to the high BOI target words. So suggesting there's a facilitatory effect of that previous sensory-motor experience that is more strongly associated with the high BOI targets. Well, we have, as I mentioned, we have found BOI effects in a lot of different tasks. So have other researchers. And one of the things that we are particularly interested in, of course, is acquisition. And one of the challenges we had was that the BOI ratings we've been using in our studies and other people have been using in studies all come from adults. So adults are considering the adult human body when they make those ratings. And we were interested in whether, first of all, whether those ratings would be different for child bodies, because children are capable of different kinds of interactions with objects. Ease of interaction is going to be different for certain concepts for children, although largely overlapping with adult experience. And so recently we collected child BOI ratings. We asked parents who had children in a particular age range of 4 to 8. We asked them to consider their child's physical experience, their child's sensorimotor experience, and provide ratings of thousands of concepts, thousands of words referring to concepts. And what we found was the ratings were indeed similar to the adults, but also different. So there are some concepts that children have quite different experience with than adults do. And further, and more importantly, what we found was that was related to acquisition. So words for which children have easier physical interactions tend to be acquired earlier. And this is really just correlational data consistent with the idea that children's early acquisition of concepts and the labels for those concepts come through physical experience, but tying it back to the BOI dimension. And of course, this is controlling for all else that predicts acquisition, like frequency and concreteness. So, sure.
Go ahead.
Sorry. Beyond acquisition, is there any link between the BOI measure index and basically the duration of the concept into the cognition framework? As an example, can we say that it takes less effort to maintain a ball in the cognition capital versus something with a lower BOI index? This is my question.
Interesting. So not quite sure what you mean by duration. I mean, what I can say is people, so if you were doing a task where you just had to say that something was a word or say that something was, referred to a real object, you would be able to do it more quickly for high BOI words. There also are some differences in fMRI. So we've done a few studies with the BOI dimension and fMRI and found that high BOI words tend to show selective recruitment of areas of the cortex that are linked to kinesthetic memory. Inferior parietal lobule is one of them. Yeah, so I'm not sure exactly what you mean by duration.
It might be a linguistic problem. Peux-tu me dire en français ce que tu veux dire par durée?
À partir du moment où le concept est acquis dans le capital cognitif, par durée, je veux dire le temps que ce concept.
It's referring to the, well, of the correlates that you were referring to. One of them that you didn't mention was age of acquisition, or did you?
Well, those were the data I was just showing you, our age of acquisition. And so there is usually a relationship where high BOI words are generally acquired earlier.
Voilà, ça,
yeah.
ça c'est la réponse. Okay, that's the answer.
Okay.
High
Okay.
BOI words are acquired earlier. That's
Yeah.
it.
Yeah. We've also done, I mean, BOI is kind of a coarse dimension. There are lots of different ways the body could be interacting with some of these concepts. And so we have drilled down on that in some recent work and found that BOI is largely about graspability. So things you can grasp more readily tend to have higher BOI. There are other ways, of course, that you can have more of a kind of all body proprioceptive sort of experience with an object. But largely when people think about body object interaction, they're thinking about their hands and they're thinking about grasping. So in general, what we found is consistent with this prediction that I was laying out at the outset today, which is this idea that things that have more sensorimotor experience tend to be associated with more sensorimotor richness. Suggesting that sensorimotor information is important, but so far I've only been talking about concrete, what people typically call concrete concepts. So things that have a lot of perceptual experience associated with them. And the truth is that if you think about the average adult lexicon, less than half of the things you have labels for are concrete things. Most of the things you have labels for are abstract things. And so a big question, big challenge for embodied cognition is abstract words. How do we acquire them? How do we retrieve them? How do we represent them? So I want to clarify something too. So I've been talking about concreteness like it's this, sort of bimodal or binary concept, so that you've got things are either concrete or they're abstract. And of course, that is not an accurate characterization. Certainly there's a continuum, and even this continuum is describing a limited aspect of what people think of when they talk about concreteness. But this is the one we're going to work with because this is what people have actually been asked to rate when they judge concreteness. So the continuum ranges from things that are directly experienced through one of the five senses, doesn't have to be vision, could be manual, smell, whatever. And then on the other end of the scale is abstract meanings, which traditionally have been defined as things that cannot be experienced through the senses. And there's many reasons this is unsatisfactory, but one of the reasons this is unsatisfactory is that it's defining abstract meaning by the absence of something. And so it's really not giving us any clues about, okay, well, if it's not experienced through the senses, how is it experienced? Because I have meanings for these things and I can talk about them. Things like love and infinity are concepts that people are quite comfortable with. And so if you can't experience them through the senses, how the heck do you learn them? How do you retrieve them? And how do you remember them? So this challenge of abstract concepts is something that many people have written about. It's a challenge for embodied cognition. It's also a challenge for other theories as well. And it's a challenge developmentally because, as I mentioned at the beginning today, we don't have very many data points. I'll try and tell you about some of the ones we do have. But the research has tended to focus on infancy, looking at the effects of sensorimotor experience on language and conceptual processing, with very little mapping beyond infancy in terms of what's changing, right? We have ideas from people like Piaget about symbolic cognition coming online, but not a lot of detail about what that would involve. So this is a picture of, just a little context. This is a picture of Max. He's the son of one of my graduate students. And during COVID, they were doing walks in Calgary, as many people were, came across these inspirational stones that people had scattered around. He liked this one because it said hope on it, and he held it up high and said, if I hold it up high, maybe COVID will be over. So he was having quite an embodied experience with this very what traditionally is considered an abstract concept. And so I think is a nice example of the limits of our understanding of what is abstract and our perhaps the constraints we've put on the extent to which abstract concepts might indeed be embodied. So that's what we'll launch into now. Some of the things we know about abstract concepts is that they're highly heterogeneous. They have been tended to be lumped into this one category of everything that doesn't have a clear perceptual referent. But in reality, we're starting to realize in recent work that there are many different types of abstract concepts. And so I want to talk a little bit about how we might be acquiring these concepts. So this is an interesting set of data. So this is from vocabulary testing across childhood. It's cross-sectional, but this is from a study by Marta Panari. And what she did was to try and say, well, when are kids acquiring these abstract concepts? What age are they acquiring them? And is there any sort of inflection in acquisition that might suggest there's some key moments in acquisition that we could drill into? So what we see is that at around age 4, only about 10% of the average child's vocabulary is made up of what are conventionally called abstract words. But by the time the child is approaching adolescence, this is nearing half of the child's lexicon. And the blue line here is something Marta added, and she argued that what she was finding in analyses was there was this modest inflection around age 8. So there was something happening around age 8 that led to a slight increase in this otherwise quite steady acquisition of abstract vocabulary. And so that provides some interesting, an interesting opportunity to think about what else is happening at this age that might be critical. Sorry about my alerts. So I want to talk about 2 proposed mechanisms for abstract vocabulary acquisition. One of the mechanisms I'm going to call the language account, or the learning through language account. And it's the idea that the meanings of abstract words are learned somehow through language. One of the proposals, so there's different versions of the learning through language account. One is something that comes from work by Lila Gleitman and colleagues. We could call it syntactic bootstrapping. It's this idea that in syntax and the constraints that puts on the use of language, the way we use words, the way we organize words, that provides clues about, that structure provides clues about meaning, and that children can start to make inferences from that and build up an abstract vocabulary. The other possible mechanism is one that's been described in a number of different contexts, some computational studies as well. It's this idea that that words gain meaning through the company they keep is one way of describing it. So it's through association or co-occurrence with other words that that children learn the meanings of words. They learn the meaning of a word because it occurs in the context of other words that are known. And that leads to a prediction that we could test. And that prediction is that children should be sensitive to contextual diversity. Meaning, so contextual diversity is in psycholinguistics, something you can characterize computationally, and it's essentially the notion that some words only occur in certain contexts. Physics terms, for instance, may only occur in physics textbooks, but other words, things like belt, occur in many contexts. So it's certainly related to perhaps a measure of ambiguity or polysemy, but it's something we can characterize. And given these mechanisms, the prediction would be if a word occurs in a lot of different contexts, if it has high contextual diversity, that should help children with acquisition. And so you should see some sensitivity and some effect of contextual diversity in children's language processing, particularly for abstract words, if this is a mechanism that is particularly important for the acquisition of abstract concepts or abstract labels. So that's one mechanism. The second mechanism is the affective embodiment account. And this is the idea that emotion might be particularly important to acquisition of abstract concepts. This proposal came from some observations. So one is that if you look at the valence, so the emotional valence of abstract and concrete words, it tends to be higher for abstract words. So abstract words on average tend to be more valenced, have more emotional connotation than concrete words, which was an interesting clue, some people thought. The other is just the notion that, the other observation is just the notion that children are often learning labels for emotions in the context of bodily experiences. So if you think about, for instance, a child being hugged or embraced and hearing "I love you" or the words "love" or other words referring to similar emotions, they do actually have a bodily experience to link this label to. And so it could be through affect or through emotion that children ground the meanings of abstract concepts. So this is kind of emotion bootstrapping is the idea. And the prediction from this account is, again, one we can test. It's the idea that children should be sensitive to valence, especially for abstract words. And we can test children's sensitivity, and that's what we did next. So we wanted to test children's sensitivity to emotion information or valence, but realized quite quickly, looking at the literature, that there hadn't been much work like this. There have been a lot of studies with adults looking at memory and emotional enhancement of memory. But these studies were largely with adults, or there were a few with children. And in the case of the child research, the stimuli were images, not words, and we wanted to present words. So what I wanted to do on this slide is just summarize what we can infer from the adult literature in order to have some predictions for children's sensitivity to emotion. So, because we're going to test it with memory in this particular study that I'm going to show you. So there are two components in the adult literature to emotional enhancement. Things tend to be better remembered when they are more negative in their emotional meaning than when they are neutral. So this is the negativity effect. It's believed to be due to an attentional bias. So we tend to be vigilant about negative information is the account. And this is something that has been observed before in children with memory for images by about age 7 or 8. So it's something that seems to be an earlier emerging aspect of emotional enhancement. The second aspect of emotional enhancement in the adult literature is the positivity effect, which is better memory for things that are positive in meaning and compared to neutral. And this positivity effect emerges later. So it's only been observed before with adults. And the account is that it's because adults have figured out some emotion regulation skills, which include looking at positive things to make yourself feel better, is the gist of the account. So if we, in this study, are going to go look at children's memory for words that are negative, neutral, and positive in meaning, we have some predictions about how their memory might be affected by the emotional aspects of meaning based on these adult findings. So what we did is we gave children a lot of words. We presented them auditorily to children who came into the lab. And we presented the words to them, and then they did a short distractor task, and then we tested their memory with a recognition memory test. So we had 87 children aged 7 to 8, and we also had a group of adults. And the stimuli were, the items were 120 words from this sort of 2x3 factorial design. So the words were either concrete or abstract, and then they were of 3 different emotion types. So we had negative concrete words, negative abstract words, neutral concrete, neutral abstract, and so on. And importantly, we selected words that should be known by children in this age range. So they have an age of acquisition that suggests these are words that children should actually know, which is an important step that hasn't always been taken in research with children, particularly when you're going to compare their performance to that of adults. And remember the affective embodiment account, that's what we're testing in this particular study. And the prediction of that account is emotional grounding for abstract meaning. And so if that's the case, what we would predict is an interaction of valence and concreteness. So valence should, if valence influences children's memory, it should do so only for abstract, or particularly for abstract words, and less so for concrete words.
There's a question.
Sorry.
Sure.
So is there any link between that negativity effects and the increasing slope in the number of words that we saw a few slides before?
I don't know if anyone's done that analysis, but I think that's an interesting idea, because yeah, if you think about what happens around the point of the inflection, yeah, children do start to learn more negative information. There's also kind of there's potentially just like a size of vocabulary that happens where there's a sufficient number of other words to associate the meanings of new words. Literacy is also something that's happening. So children are seeing words in many different contexts in books, which I think may also be important. There's advanced mental state inferencing that's happening about that age. So yeah, but that the link with negativity, I don't have an answer. I think that's an interesting idea.
Thank you.
I have another question.
Another question.
Is in that
Sure.
context about people that speak more than one language. So auditory usually is, affected, or the vocabulary is also affected. One word might mean, even though it sounds the same, might mean two different things.
Yeah.
There's also the tone of it, or like how negative or not negative it is. So in some cultures, some words are negative, some words are not. This includes cuss words and other things, curse words.
Yeah.
Things. So I'm not sure if that has an impact in the studies that are being done, because usually it's either English-based or on adults, which, again, you talked about, but English-based is so, how can I say? English is it's not super sophisticated as a language, so there are more languages that are more complex, and people that speak more than English usually are they part of these studies, is what I'm saying, or is it just based on English people speaking?
Yeah, the ones I'm showing you today, these participants all had a certain proportion of language, which was English. So some of them hear other languages at home, but they had to have a good chunk of their linguistic experience needed to be in English. So that's limiting. There is some research on some of these semantic effects in bilingual participants and adults. And what they tend to find is that in L2, the semantic effects, so things like BOI, things like valence, the effects are attenuated. So the effects are smaller in the second language than in L1 or the usually earlier acquired language. So there's a little bit of that work happening around semantic richness effects in general, but with adults, but not enough.
Got it. Perfect. Thank you so much.
No problem. Yeah, but you raise a good point about prosody too. And I should say that these stimuli were carefully constructed. The auditory stimuli were carefully engineered so that the valence wasn't being cued by, as far as we could tell, there was no prosodic marker of valence that was associated with the stimuli. So the children heard the words and on the retrieval task, and then they were asked to be word detectives. So they were just saying, is this a word you heard earlier today? Press the green button. Is it a word that you didn't hear earlier today? Press the red button. And so in that way, we were able to get recognition memory data from the children and also from the adults. And these are some of the data. So one of the things about memory data, of course, is that there are several different indices of memory performance. So I'm going to show you hits, and then I'm also going to show you D prime, and both they're different ways of looking at memory accuracy. Overall, I wanted to comment too on the fact that the children perform just as well as the adults on this task, which I think is notable. There was a lot of stimuli, 120 stimuli is a lot to remember. But overall, the children's accuracy was a bit more variable, but it was on average as good as the adults, perhaps even a little bit better. So for hit rates, what we found, remember we were predicting that interaction of valence and concreteness. We did find the interaction. So valence only affected hits, so accurate detection that they had seen this word before or heard this word before. For children, there was the negativity effect only for abstract words. For adults, there was both a negativity and a positivity effect only for abstract words. There was not a significant effect of valence for concrete words for either group. So this by itself is consistent with the predictions of the affective embodiment account, suggesting around age 7, 8, children are sensitive to valence information. It's part of how they are processing the meanings of words, and it's therefore influencing their ability to remember those words. Now, I said we also looked at D prime. So D prime is signal detection, based on signal detection analysis. It's a different way of characterizing memory accuracy. The results here are a little different. We found valence effects and we found concreteness effects, but no interaction, only main effects. So the children again showed a negativity effect, but it didn't interact significantly with concreteness. And the children also showed a concreteness effect, so better memory for concrete than abstract words, and the adults just showed that concreteness effect. So mixed. So if you look across multiple measures of memory accuracy, the picture is a bit more mixed. Okay. I want to tell you about another study we conducted, which allowed us to test both of those mechanisms for abstract vocabulary acquisition that I mentioned before. So these data are from a large vocabulary acquisition study where participants between grades 2 and university age, so we call that grade 16 is the final university year. So participants had vocabulary tests conducted cross-sectionally between grades 2 and 16 for thousands of words, thousands of children. These are data that are publicly available by Mark Brisbert. And so they're a great resource for looking at vocabulary acquisition across a wide developmental window. And these data are something we took advantage of to test both the language-based account and the affective embodiment account. So we had a language-based predictor, which was semantic diversity, so a measure of the different semantic contexts in which words appear. So this allowed us to test that idea that words that appear in more diverse contexts should be learned more readily or acquired more readily. And the prediction from that language-based account is an interaction of semantic diversity and concreteness. So this should be particularly pronounced for abstract words. And then we also were able to, again, test that emotion account, the affective embodiment account. We used valence, data on valence for each of these words and examined the valence by concreteness interaction.
Can I ask you a question?
Sure.
What about polysemy when you're doing contexts?
I'm going to get to that in about 2 slides.
Okay.
Because we have some new data that address that question. Yeah, that's a great question. So these are the data. So this is a retrospective post hoc analysis of existing acquisition data, but also other existing psycholinguistic norms. And so we had a set of about 10,000 words that we were able to look at. On the left, on the y-axis, is age of acquisition. So this is the grade at which the word was acquired on average in those Brisbert vocabulary acquisition data. We've got semantic diversity on the x-axis. So it goes from left to right is low to high semantic diversity. Remember, the prediction is semantic diversity should help with acquisition, particularly for abstract concepts. And so what you see here is that semantic diversity does help. So words that appear in more diverse contexts are acquired earlier, but that is true for both concrete and abstract words. So no difference there in terms of, so no interaction, but 2 main effects. And then we did the same, used the same data, the same almost 10,000 words, and looked for the interaction of valence and age and concreteness, and indeed found the interaction. This is an interaction that was is also replicated in a different age of acquisition data set, a different acquisition data set by Marta Panari's group. We also recently looked at verb acquisition in particular, and again found this interaction. So this seems to be quite robust. So the gist of it is that, so we've got, again, age of acquisition, the grade acquired, the grade at which the word is acquired on the y-axis, Valence is across the bottom. Valence is a bimodal dimension. So negative is low, positive is high, neutral is in the middle. And what you see for concrete, for the blue line, is that in general, there's a slight tendency for positive concrete meanings to be acquired earlier than negative concrete meanings, but it's slight. The more pronounced effect of valence is for abstract words. And here you see that if something is valenced, so if it's abstract negative or abstract positive, it tends to be acquired earlier. And the latest acquired words that we examined were those neutral abstract meanings. So that there's something about valence that grounds or advantages abstract meanings and allows them to be acquired earlier. But the trickiest meanings for children to acquire are things that are abstract and also neutral, where they can't use emotion as an acquisition mechanism. That would be the explanation I would offer. So polysemy. So recently, we again took a look at some of these large-scale acquisition data. So these are again the Brisbert acquisition data. But what we noticed was, so in the Brisbert data set, they actually tested acquisition of a lot of polysemous words. And what's really interesting in the data set is that they tested acquisition of specific meanings. So if you take
can I just check if they understand? Polysémie, vous savez ce que c'est? Polysémie. Ça veut dire une forme de mot qui a différents sens. Comme pomme de douche, pomme comme fruit et pomme de douche. Ça, c'est polysémie. Il y a des mots qui sont très polysémiques, c'est ça. Sorry, I have to make sure that we pack crap.
No, I really appreciate the backup. So if you have a word like state, state is purportedly concrete based on the concreteness ratings that are understood. And the early acquired meaning of state in the Brisbert and B. Miller data is indeed quite abstract. It's just, Texas is a state. These are American acquisition data. But what's interesting is that if you look at the later acquired meanings, so you can actually unpackage the different meanings of state. You can look in the data at the age or the grade at which that particular meaning is acquired. And what was the question for me was, it looks like, as I look at these different meanings and the grade at which they're acquired, it looks like some of these things that start as quite concrete in terms of the early acquired meaning, later acquired meanings seem to be increasingly abstract. And this would be an interesting way to examine how abstract meaning is acquired. Whereas something like grace, so the prayer that one says before a meal, begins, the early acquired meaning of grace is quite abstract, and subsequent meanings are quite abstract as well. But this particular data set presented an opportunity to look at acquisition of meanings across development, again in a cross-sectional way, but would provide some interesting insights. Because the truth is, most words have multiple senses. We don't typically examine the psycholinguistic properties of each meaning separately. So typically we just say state is a concrete word, but the truth is it has meanings that are actually quite abstract. And how does that map across development? That was the question. So to address that, we had to get concreteness ratings for each specific meaning, but that's what we did. So here are the data. So what we've depicted here in green is acquisition of meanings of words that began as quite concrete. So if it's green, it was a word that typically we just consider as a concrete word, like state. So state is something that initially has a concrete meaning. It gets categorized as concrete. Of course, meaning is more dynamic than that. Meaning is something that changes across development as new meanings are acquired and understood. And so what this shows is that something like state, while it might early on have a concrete meaning associated with it, the meanings that are subsequently acquired seem to become increasingly abstract. Whereas things like grace, which are represented here in terms of the blue line, at early grades, grace is quite abstract. it acquires additional meanings because it's a polysemous word across development. Those meanings are also abstract. So as we think about mechanisms of acquisition for abstract concepts, the idea is something that might initially be acquired through sensorimotor experience because the early meaning that's acquired is a concrete one. Across development can become something that has quite a lot of abstract meaning associated with it. So this is an additional idea about acquisition of abstract meaning, is that you might first build a representation or hold a meaning for something that's acquired through sensorimotor experience, but then that label doesn't stay limited to that particular meaning, of course. It acquires other meanings across development. Okay, so an interim summary of what I've told you in this second section about acquisition. Consistent with the idea of affective embodiment, I've shown you evidence that children process and remember valenced abstract words more readily. I showed you only the data from the remember part, but we've also looked at children's processing through things like lexical decision performance, and again found some similar evidence that valenced abstract words might be processed differently than neutral abstract words. So the implication is that valenced abstract meanings do seem to be acquired before neutral abstract meanings, and that the particular challenge for children is those neutral abstract meanings. They might be the ones that rely most heavily on acquisition through language mechanisms. And then consistent with those language mechanisms, we, as I've shown you in this most recent data set, found that concrete word meanings do become more abstract across development. But I think I would have to offer the caveat, which is there's some evidence for these mechanisms in the data I've shown you, but this is limited evidence because the mechanisms aren't necessarily specific to abstract meaning, which is, I think, how they had been characterized or framed when they were initially proposed. And we're still left with this question of what is the stuff of abstract words? I've argued that sometimes emotion is the stuff of abstract words, that sometimes building upon earlier concrete acquisition might be the stuff of abstract words, and that language might be important, but I haven't got very specific about what that would mean. So what other clues do we have about what abstract words mean? So I want to tell you about the dissertation work of Lenka Radislova. This was a study where she asked adults to convey the meanings of concrete and abstract words to a partner. So this is similar to a game you might have played. Sometimes it's called Taboo. The idea is that you, as the clue giver, are given a word, but only you know the word, and you have to get your playing partner to come up with the word, but you can't use the word. So the word is taboo, but you have to somehow get the other person to guess what the word is without using it. And so she took advantage of this kind of paradigm. She brought pairs of adult participants to the lab. They were videotaped so that we could code both what they said when they tried to convey the meanings of these words, but also how they gestured. And so we did a lot of coding of gesture and also of verbal utterances. And crisis is an example of one of the words that a participant would be given. It's a more abstract word. So we had some abstract and some concrete words that each pair of participants had to guess. Sure.
Question that I don't understand about what the subjects are doing. They're allowed to say words, but not the word in question.
Yeah.
And they're allowed to gesture and imitate, like in charades.
Yeah. Yeah.
It's two different things.
Well, that was what we hoped. We didn't want to limit people to. So now, to be clear, it's not like charades. So they were not told, act this out. Any gesture that they're doing is incidental, right? So their main goal was to get the other person through description to come up with the meaning. But in addition, they tended to, because this was quite challenging, they gestured a lot. And some of it was iconic gesture, as I'll talk about, but other gesture was just kind of the beat gesture that you do to try and support your own verbal fluency.
Voting.
Okay. So we coded thousands of utterances, thousands of gestures, and looked at how the different words and gestures that participants produced differed as a function of whether the cue word was concrete or abstract. So for conveying concrete meanings and getting your fellow partner to guess the meaning of concrete words, participants referred a lot to objects, to entities. They used iconic gesture. So one of our cue words was beverage. And so there was, of course, a lot of iconic beverage drinking that was gestured. Abstract meanings, quite different in the types of utterances that people used, the descriptions that they offered, and also in their gestures. So to convey abstract meaning, participants used a lot of reference to people, the guesser themselves, but also other people. They referred to a lot of introspection, a lot of introspective states, mental states, and they gestured a lot. It was less iconic. Some of it was still iconic, or at least metaphoric. So for instance, for the cue word decision, several participants used this gesture. One of the cue words was loyalty, and participants would gesture as if they were petting a furry pet. And then they were a large number of beat gestures, just reflecting, I think, the difficulty of conveying some of these abstract meanings. And really, beat gesture is something people tend to do implicitly in order to support fluency. So some important clues there about what abstract meanings might be made of. And I wanted to highlight this social or self-referent or other referent aspect of a lot of the descriptions of abstract words. So many of participants' descriptions of abstract words, this is the sentence from the paper, but they talked a lot about the self or others. They situated the concept in an interpersonal context, and made many references to internal states. And by that, I mean things like intentions, beliefs, emotions, and motivations. So they made things quite social. And that led to this thought that we had, and that others have had as well, that maybe social information, social relevance, might be particularly important to abstract concepts. And it might also be another clue about the stuff of abstract meaning. Now, what do I mean by social significance? Well, good question, because this is something that has been studied in the literature. There is a whole literature about the social brain, about the salience of social stimuli and how that gets processed in a neural paradigm or with neural markers. So for instance, there is some well-replicated research showing that social as opposed to non-social stimuli tend to show stronger activation in the dorsolateral anterior temporal lobe. And there's also this work from the psycholinguistic literature saying, social might be really important for abstract concepts, but very little clear, rigorous test of that idea. And one of the things we noticed in starting to wade into this literature about socialness and the social brain was that each set of researchers sort of had their own characterization of what social meant and devised their own set of stimuli. And of course, as someone who approaches this as a psycholinguist with a preference for thousands of stimuli, that was unsatisfactory. And so to begin to wade into this question of, is socialness important, particularly for abstract concepts, we decided we needed to devise some stimuli on a consistent rating scale. So 2 questions for this last portion of the talk. Is a broad inclusive dimension of socialness reliable? So wanted to approach it much as we'd approach things like body-object interaction. And more importantly, does that dimension of socialness, should we be able to characterize it, does it matter for behavior? So recently we quantified this socialness construct. We decided to go with a very broad and inclusive definition and see if that would be reliable. And it turned out it was. So we gave people a big inclusive definition of socialness. They were quite comfortable with that, and produced ratings that were relatively invariant and quite reliable. So people told us consistently that custard is not very social. Family, on the other hand, is very social. So we've got this construct. We have it now for thousands of items. But of course, the more important question is, does this matter for behavior? Because if it does, it suggests that socialness is an aspect of the meanings that people are processing when they are doing our lexical tasks. So we have looked at behavioral effects of socialness now in several different tasks. Some of this is just being written up, but this was a first attempt in a previous paper where we just looked at lexical decision, which is a simple word, non-word distinction. And we put lots of other things in the model in explaining lexical decision behavior, things like length and frequency that are usually the biggest drivers of lexical decision behavior. But in addition, we added some semantic predictors: socialness, concreteness, valence, semantic diversity, those dimensions you've already heard about today. And we did find a modest effect of socialness. So things that were higher in socialness ratings tended to be responded to more quickly and more accurately in lexical decision, even when we'd already controlled for things like length and frequency and other semantic dimensions.
Sorry to interrupt again, because we have computer scientists here. Lexical decision task is you show what looks like a word, and the participant has to say whether it's a word or not.
Right. So the stimuli are either real words or non-words that are usually orthographically legal. They're usually, plausible, but they don't have meaning. And so it's a fairly shallow task in that people don't need to think extensively about meaning. They really just have to assess. There's theories of lexical decision, but the predominant view is that lexical decision is just based on some kind of familiarity. So a sense that this word form is one I have encountered before. So minimal meaning processing. So you tend to find quite modest semantic effects. Okay. So the last thing I want to show you today is an attempt to bring these things together, because I have, I don't want to be guilty of spending my career just adding new dimensions to the lexical semantic space. Instead, I want to offer you some kind of overview or synthesis, because I've told you today about body-object interaction, about valence, about socialness, about semantic diversity, about concreteness. There's a mounting pile of lexical semantic variables that I've said are important. So one of the things we did recently was to use some of these new data that we had collected that give us values for words on their meaning properties, and to do a big factor analysis and network analysis. So to try and see, how do these things fit together? I started today with this notion that there might be multiple dimensions to semantic representation. And so we can capture some of that with some of these particular ratings dimensions. So in this factor analysis, we have multiple measures of sensorimotor experience. So this goes beyond BOI. So there are new norms that people have collected that specify exactly which kind of sensorimotor interaction we're talking about, down to the particular effector or bodily system. So those are the sensorimotor experience norms from Dermot Lionett and colleagues. We also have our new socialness dimension to try and capture some of social experience. We've got the emotion dimensions, which are usually valence and arousal. And then multiple measures of what I would call linguistic experience. So things like semantic diversity and age of acquisition and frequency that capture some of your sort of episodic history with word forms. So put all of this into a factor analysis. And so this is a factor analysis with over 6,000 words, which is the largest we've ever conducted. So it's probably the largest factor analysis of semantic space that's been conducted with word forms. And we have a 6-factor solution. One of the big questions I had was, where will this new socialness dimension that we've characterized, where will that land? Because going into our work on socialness, I really thought maybe socialness was just emotion. And so would socialness really capture anything different from emotion? And so it's interesting, first of all, that socialness and emotion are very weakly correlated. But in the factor analysis, socialness lands in this area I've highlighted with the gold square. Socialness lands with auditory information and head and mouth action. So suggesting there's a real sort of communicative element to this, to the socialness that we've measured with this dimension. Also interesting that there are 2, what I would call sensorimotor factors. So one is about body action. The other, that 6th factor, is more about hands and vision and the coordination of those 2 things. And then emotion is actually its own factor, and we could dig more into the factor structure, but we don't need to today. Suffice it to say, socialness does seem to be something distinct, but an important point, because we came into this with the question of, is socialness particularly important for abstract concepts? The factor solution is similar for both concrete and abstract concepts, and the effects of socialness seem to be similar for concrete and abstract concepts. Socialness does not seem to be a particular dimension of abstract meaning. It seems to be a dimension of meaning, but one that is relevant for both concrete and abstract concepts, right across that continuum. And last, we have a network analysis, which is a different approach to the factor analysis data, a high sensitivity network. And so it's just a different way of characterizing. So the size of the links between the different predictors in each factor gives you a sense of strength of association. And the color tells you something about the directionality. And then we were also able to look at centrality, which I think is interesting and quite, I think, notable, that interoception, which is this new dimension of meaning closely related to valence, but distinct from valence. Interoception is something that is of growing interest, I think, in people working in semantic representation. Not particularly well specified yet, but interesting to me that it shows up as so central to this network of factors within semantic space. Okay, so the point I want to leave you with today is this idea that there are multiple dimensions that are important to the grounding of both concrete and abstract concepts. And that it's very likely, as you could see in the network analysis, the relative weighting of the dimensions varies as a function of concept and also of task demands. And that's consistent with what I would say is in the weak embodiment space of that continuum I showed you at the beginning. So using this red box here to show where I think our data are best explained by a model that allows for multiple dimensions of meaning, where sensorimotor information is important and it's constitutive of meaning for some things, but not for everything. And so simulation is going to be an important process, but probably only partially, if you want to be able to explain our knowledge of all concepts. And so, yeah, meaning is something that is flexible and dynamic and changes as a function of development, but also changes as a function of the context in which you are deriving the meaning. And so, yeah, so just want to end today with thanks for your attention and interest, and big thanks to my collaborators and the folks who fund us. Thank you.
Thank you very much, first of all. You can't hear the online now. We're open to questions. I hope that both the faraway people and the nearby people will ask questions. As usual, there's going to be a period of silence for a few seconds. I will have to break the oh yes, you have to go. Okay, bye-bye, Meredith.
Maybe I have a question.
Go ahead.
A silly question, but is it fair to say that most of the time abstract concepts have bigger impact on our day-to-day life versus
I think so. I think so. And I think they are, I'm particularly interested in the role they play in our mental lives. I think that is underexplored and is something that, yeah, I would like to direct some more sort of systematic work towards.
Could both of you give examples of why you think that?
Yeah, I mean, I think obviously food is important for survival, and food is, while a general term, pretty concrete. And so there's so I think importance is a tricky thing to qualify. But I think if you concern yourself with the concepts that give life meaning, for most people in a subjective way, they tend to be abstract concepts. That's how I am interpreting the question.
And your interpretation?
I'm just referring to my, I think, own experience when I compare, I don't know, love, hate versus a chair or a table. I tend to think that abstract concepts have bigger impact on my day-to-day life. And if yes, how would you, do you think that the impact criteria is part of the valence that you talked about?
Yeah, so valence, also arousal to some degree, although valence tends to be the more important predictor in any kind of analysis that we do. So yes, I think some of it is captured in valence. I think some of it is captured with that poorly defined interoceptive bundle that I was introducing just at the end of the talk today.
Thank you.
Others? Otherwise, I'm not at a loss. Okay, let's start. Oh, wait just a second. Also leaving. Oh, okay. Go ahead, Rushen, go ahead.
Hi, great talk. Thank you. I
thought you were asking a question.
No, I have yes, I am asking a question. First, I want to say it's a great talk. I enjoyed it. The general question, I'm just thinking, it seems to be you're trying to say for this learning of either abstract or a concrete meaning, they depend on sensory information, but also social affective information, right? And you can measure that. But can we assume that ultimately, at some point, children who grow to be adults, that everyone in the society in a particular linguistic group would share the same meaning for a particular concept? If we share the same meaning, how can we conceptualize that? How do we understand that if we end up having the same meaning, even though our experiences with sensory, whatever experience, social experience, contact with the world is so variable? How come we end up having the same feeling for the meaning, especially abstract meaning, where the exposure to the world, all these dimensions are quite subtle? It cannot possibly be the same, right? Unless we are given the definition in school, everybody will have that definition. But I imagine the kind of words you used depend on your exposure to the world, right?
Yes.
They're not specialized a certain kind of abstract meaning for certain chemical elements or something, right? So they're really, So how do you explain that? Or do you think we never arrive at the same meaning? My feeling with the linguistic representation, we all end up with the same intuition, even though there may be some variation. But some people think that children are, like Chomsky thinks children are prepared. Blind children, doesn't matter if they see or not, they would end up, it's like, it's a very easy explanation for him. It's just, we are prepared to accept everything. You still have to explain, but still puzzles me how the variation ends up to be a uniform output.
No, it's so really nice question. And I think I'd say a couple of things. One is, I think perhaps the contexts are more similar than we believe. I think there's sort of the tendency towards human exceptionalism, right? To believe that my experience is different than everyone else's. And I think there are lots of indications that the contexts are actually remarkably similar, at least within a culture. And so there's some interesting work, certainly on differences in meaning across cultures. And across languages where there are, you can sort of isolate the contextual, experiential aspect of development and the way we arrive at meanings. The other thing I would say is there are probably more individual differences in meaning than we have yet identified. And the reason I would say that is because I think, in cognitive science, we've had this tendency to assume we're all walking around with the same system, and that there's this sort of knowable cognitive system that we can study, and it's largely invariant across individuals. But I think there's, at least in my subfield, there's growing appreciation that even things like ratings of body object interaction may be a function of your experience. So we ask you not to consider your own experience, right? We ask you to consider the average human body, but we're finding there are some differences as a function of people's own experience. And so that's a whole lot of noise that we have not really captured or measured particularly well when we use ratings from one group of people to predict behavior of another group of people, which has been our general approach. So I'm increasingly interested. One of the things we have done in a recent study was to measure people's imagery skill, and found that is a predictor of their reliance on body object information in language processing. So you can separately quantify, even in a sort of undergraduate population, healthy adult undergraduate population, there's variability in people's motor imagery ability. Some people are very good at imagining things like their hands taking different positions, and other people are less adept at that. And that then predicts the extent to which they use sensorimotor information in language processing. So those sorts of individual differences, I think, are opening up some new avenues to study the variability that exists in a system that previously at least I was guilty of just saying, if we figure this out for one group of people, that will probably tell us about how everybody's doing this. But there are perhaps different modes of cognition that we need to be separating.
Thank you. Follow up on that. If, for example, the individual differences really depends on your own, for example, experience, does that mean that our meaning for certain words, either concrete or abstract, could change over time during your lifetime, depending on how you end up experiencing the life, right?
Yes.
And, but somehow intuitively we feel it's stable. Once you learn the word meaning, it's pretty stable. But you would say, according to your model, that it's a dynamic situation. Your meaning for the words could change during lifespan.
Absolutely. And it could be short-term kind of, contextual priming, and it could be long-term experiential, more episodic kinds of effects. Yeah.
Okay,
The
thank
trouble
you.
with all this is we don't know, I still don't know what you mean by meaning. But there's a question from Arsenia. We'll get back to that. Arsenia says, thank you so much for this amazing presentation. I really liked your slide with the boy who was holding up a rock with the word hope. And I found it was your son, right?
It's my graduate student's son. Yeah.
Okay. And I found it's interesting that people associate positive concepts with upward movement as opposed to downward. I was wondering what you think about this kind of embodiment of emotional valence, as well as metaphors that use body parts versus metaphors that are not embodied, and how does it impact your acquisition?
Yeah. So I think there is certainly there's evidence that there's generally this tendency to, this up is good, down is bad metaphor. I think while people know that and they can use that in certain contexts, they don't always. So we've done some studies looking at fairly shallow processing and seeing whether people will kind of in an obligatory way access that spatial metaphor of up is good when they're processing just sort of shallow lexical meaning. And we find, although there have been some studies that have shown that, that were published about a decade ago, we haven't been able to replicate those. And I think it's probably the case that people can be aware, they can use that information, but it's not necessarily the case that they will, especially if it's a task where there isn't extensive semantic processing required. So yeah, I think absolutely the use of body parts to extend cognition, the metaphors that include some of that spatial position information. I think people know those and they're aware of them, although some of them are culturally bound for sure. And they are encoded in language. So there's statistical regularity about the way these things are encoded and could be learned through language as well. But I think that there's mixed evidence about when in lexical semantic processing.
Okay, other questions from here or from there? If not, I was afraid at first that we would agree too much, Penny, but there are plenty of things to disagree about. First of all, for me, well, many of these studies use or rely on the Briespart norms, and the thing is that when you give, and even in your own studies, when you give things to subjects to rate, it's not clear what they're rating them on. You can tell them till you're black and blue, do it on this, not on this.
Yeah.
They rate it on what they rate on. So that produces a huge amount of noise in factor analyses and in correlations, etc. Because but that's just an endemic methodological problem. But now I'll get to, for me, concepts are categories, but I'll get to concepts now conceptually. I think that the two possible real dimensions, even no matter what you told the subjects to rate when they're doing concreteness, the two things that influence them are the sensory motor one and the generality one. But in the sensory motor one, there's a huge amount of conflation. I think not only are interoceptive states and emotions are sensory motor. In fact, they're the most sensory motor thing you have. If you don't rate, if you rate those things as being abstract rather than concrete, everything gets thrown into gets scrambled up. Yeah. So there's not a clear solution because you can't get participants to rate according to what you think these things are. But that's a background factor to bear in mind. These really are conceptually distinct. Is this something you can feel, or is this not something you can feel? And that you can feel what it looks like to eat or see an apple, and you can feel what it looks like or to experience loving or verbs of taking. All of those things are things that you can feel. What is actually represented in the brain in those cases? Well, the question that I asked you about labels, names, or names of categories, if we could agree on that, and reference of categories. Just take the word apple. I have the word apple. It refers to that thing. The apple is the round, red, edible, blah, blah, blah thing that I can define in words, but this is not a definitional point. I'm just making that apples have properties that have names, and I can describe them with names. So what is this other language-based approach that you have? It seems to me that infinity, your favorite super abstract category, right? You can define that. Mathematicians do it all the time. So there are words to define that. And it's not, moreover, words that you use to define things like infinity use words. And those words are also names of categories. And those categories also have definitions. So there's something, and when you were talking about the evolution of meaning in the lifetime of a child, or even in the history of the language, what changes is definitions of what counts as a referent for that word. Definitions are actually telling you, they're not, descriptions describe objects, but definitions define words. And they're really defining the reference of words. What are apples? round red fruit. How do you put these into your polymodal picture?
Well, I think so there's a couple of aspects, I think, of what people perceive and are capable of characterizing that influence what we're able to measure. So one of the issues with things like what I would call the features that you just gave me for Apple is that, you know, you're able to characterize things insofar as you can verbalize them. But there are weird things about the features that people choose to provide, right? You know, so in feature norms, for instance, people will tell you that chickens have legs, but they won't tell you that, you know, a pigeon has legs. Like there's something about, you know, there's clearly other things going on that influence what people will verbalize. I think the other dimension that kind of runs or bias even that I would say influences what people characterize as concrete and abstract is just this bias towards kind of external, internal. And there's a preponderance of external information that influences, I think, those concreteness ratings and about perception externally, and a limited ability to consider or historically a limited consideration of the internal. And that's something that we could probably do a better job of measuring. I mean, on the general point, I would say there's a lot of noise. It's kind of remarkable, in fact, that you could ask one group of people about some aspect of meaning, give them a 7-point scale, which has all kinds of flaws, and then significantly predict the behavior of another group of people in a completely, you know, a quite different task involving the same stimuli. So I think that there's immense potential to get more specific, but these studies, limited as they are, provide some clues about starting points and places to drill down and get more precise.
I agree. And that now I'm sure this topic, we only have 1 minute left. So, but this topic has come up because it's coming up in the air all the time. It's come up in this series, et cetera, et cetera. When you talk about context in which words or things occur, especially words that occur, I'm sure people are asking you about ChatGPT.
Yes.
What are you answering?
Yeah, so I think so there's all kinds of interesting things we could learn, I think, from ChatGPT. I think, and I've been involved in some conversations around, you know, what's missing. Obviously, my interest in sensorimotor experience and embodiment is important, and I think there are ways in which you can tell that ChatGPT doesn't have a body, right? So I think there's a wealth of insight that we could gain from exploring, because I think I showed in the continuum that there are models that are really just about sort of distributional language models, plus give me some sensorimotor information. Like that's sort of, there are instances of those kinds of models. They're more limited than what I would say we should have, but they're out there. And I think ChatGPT is a way for us to, it gives us the language piece, and then affords the opportunity to figure out what else is important.
Well, on that contemporary note, I want to thank you very much for your very informative and stimulating talk. And it's not over.
Well, thanks for the invitation, and thanks everybody for coming. I really enjoyed getting to chat with you today.